Hello, everyone. Thanks for joining us for this talk today. Okay, we have a presentation there. So, nice to see you here during one of the last talks of the day. I hope we get to enjoy a bit of this before going to the Kapellmann to enjoy. So, let's jump straight into the topic. We want to introduce a DFIR framework for OT systems, for embedded OT systems. This is something that most likely many of you, if you're here and interested in the topic, probably have already thought about it. Like, it should probably already exist. There should be something. But right now, we're making sure that it actually, gets into something that we can start working with. And to begin, I wanted to provide an anecdote. Let's say I always like to begin like this, and it was just a reflection from a couple months ago. We were already working in this project, and then I was in a conference in Italy. And then there was this French researcher, and he started talking to us about his presentation. And he was super excited. He said how amazing it was. And he says, my presentation, The Quest of the Gecko, it's going to be great. You should go. And it sounded super friendly, super amazing. The good news is that the talk was amazing. The bad news is that it wasn't as cute as it sounded when he said The Quest of the Gecko, because this was the actual gecko. Basically, what this researcher was doing is he was working with this specific type of embedded device. It had a proprietary OS that he had to actually go and figure out how to work with it. He had to go and figure out basically everything about the device. And then he was saying that it took him a couple months. A couple months sounds pretty good, because of the complexity and whatnot. And the person that employed him or the company was very happy with the results. But the problem is that when you think about doing this with every device you have, if you were, for example, in a company, in a larger organization, it sounds almost impossible, right? Because you're not going to have one device. You're not going to have one of these. You're going to have hundreds, probably thousands. And then the only way to target, to go after this, basically to do something about this, is to have a systematic approach, right? And that is basically what we took into our hands with this framework. And this is why we defined we need a DFIR framework for embedded OT systems. We need to figure out how to make it systematic so that we can go look into the devices, know what we have, and actually incorporate it not only as something that one researcher does for 6 months, even though it's still super valuable, but something that we can go and do as part of the organization normal processes. So there are two things to consider here. The first thing is, why are we pushing this in the first place? Of course, there are a different set of benefits. The first one is, of course, that you can establish basically a baseline for the different devices that you have. Once you have a baseline, then you can know whenever something that is weird or that shouldn't be happening is taking place. So it basically enables you to have better visualization, better visibility into what's going on. And the second one, the third thing is about supporting other processes in the company. So what we're saying right now is not come and create something entirely new, but what we're saying is many of the things that you need for for having such an approach for DFIR systems that is more systematic are things that we are already doing, that already take place, and that are going to benefit in different branches, let's say, or different types of activities in the company. So, of course, for example, if you build an inventory, you're going to have something, for procurement, you're going to have for maintenance. Basically, this is something that is already taking place and that you can benefit from. And then, on the other side, of course, we have the challenges. It's not so simple. It's actually, if we're talking about a fairly complex work, it's something that, we're not bringing to you right now a full solution for everything. We're bringing a theoretical framework, something that we think that could be applied and that could be helpful for the community. So between the challenges, of course, is we have few visibility often in these devices. Oftentimes, the devices might have, for example, embedded RTOS. Like in this case, it was something proprietary that you have to figure out how to work with, that possibly the vendor is going to help you, but possibly they are not. And so also all of this is time-consuming, right? And also, it might be time-consuming simply by the fact that oftentimes, to interact with one of these devices, you need to figure out how to interact with each one. You need to probably even send someone physically to go and grab the device and physically connect to it, or whatever they have to do. And most often, figure it out. So, good news. The good news that we have is that this is something that already takes place in any organization. But the thing that we're trying to bring up in here is trying to put both together in a theoretical framework that considers both the engineering perspective and the digital perspective, right? Up until now, we have been thinking, actually, well, yeah, in general, as a community, we have been thinking as this idea of like, like engineering has some work, IT has different work. Most recently, we have started combining it, and everyone's started pushing for that. And then when you actually sit down and think through it, you realize that from engineering perspective, you already do things like root cause analysis, and those type of analysis where you are actually trying to figure out what could go wrong and how could it go wrong. And from the detail side, it's exactly the same. All of the analysis that we can do, considering from the computing perspective. So the thing that we want to do right now is to pitch a systematic approach again to do both of these together. And this is how it looks like. It's actually looks fairly simple, but obviously it comes from a lot of thinking and discussion between different groups. This included actually work from our consultants and also from our threat intelligence group and from our managed defense group. Basically everyone getting together and thinking, how should this look like? And what you see in here actually on the left side is basically our process, let's say, that our framework for incident response. It's basically something that most people are already familiar with. And why not? If, frameworks for incident response have existed forever, not forever, but for a long time with IT. We have frameworks for many different things, but not specifically for OT, where we have seen that it's fairly different, right? And then we focused specifically on the preparation phase. So we focus on the 3 things that you need to make sure that by the time you get an incident, or by the time you want to do something about something that you're unhappy that is happening, then that you have enough data, you have enough information, and you know where to go and find it, where to collect it. It's 3 basic steps, basically identifying tools and basically how to communicate with each device. The second one, collaborating with OEMs. I'm going to get more in depth into each step. And the third one, identifying and collecting the data. For the first step, device and tool identification. Okay. The first thing that we need to know, and this is first step in everything that we talk about, like OT in general, is to know what we have, to know what we want to defend, to know what we want to analyze, basically to scope the problem. And in this case, the first thing that we consider is communication methods. We have 4 different types of communications that we consider in devices. This is just like general theory. You can, of course, just have a piece of software, an application that you use for communicating with your device. You can use different communication protocols. I don't know, maybe FTP, maybe SSH, maybe Telnet, you name it, depends on the device. Oftentimes you might have a web GUI. Of course, many people are gonna jump when it says like GUI, it shouldn't. Okay, maybe, maybe it shouldn't, but they exist, period. And then physical interfaces, of course, if you're talking about like any connections, any direct cables into the device. Putting that all together, we came up with this general diagram, let's say, that would be an example of how we would approach this problem from this systematic level. And so the first thing that we would do is take a look into the vendors and assets that we have. These, of course, are not any realistic side or anything. It was just like a recollection that we did of like, which ones do you know? Which is part of the problem, right? Because no one can, most likely no one here knows all of these models and everything that they have. It's something, like that probably if you have to deal with it, you might go back, you find the documentation, you try to figure out where it is. And if you have all of this in place, that is something that is going to be much easier. Mainly considering that you might be in the face of something wrong going on, right? Like of an incident, basically. And so this first one, the D20MX, is the one we're going to be focusing on today. It's like a quick example, like some additional value that we provide today. So I'm not going to get in depth, but basically we're going to describe a bit more in depth that specific device. There it goes. And beyond the data that we were already showing there, this was kind of like a baseline of how we would like to look at this information. But we are aware that there are other pieces of data that might be very important to collect. So we mentioned here 3 particularly: backup configurations, in case there's any change you want to recover rapidly. Second one is technical procedures and manuals. If you need more information about the devices, oftentimes it's not so easy and intuitive to just go and interact, but you actually need to go and find the documentation. This is something that we actually reproduce in our experiment that we're going to talk in a couple minutes. And so, yeah, basically, it might even be open source. But basically, the time that it takes you to go and find it might be the time that it takes you to go and actually solve the problem. And then the third one is appointed employees, which is basically the knowledge, right? We want to know who is able to interact with the device, who has a knowledge of what it is, how it works, and what we can do about it. And if there's no one, then again, that's a void that you probably might know with anticipation that you might start trying to address. Because if something happens, you need to have someone that knows it. Now, that was the first step. We get all the information. We got what devices we have. We identify what tools we need to communicate with them. And then we jump into the second, which is the collaboration with OEMs. This might be a bit more, how to say, I know that some people, when you say collaboration, jump and it's like, oh, you know, that sounds worrying. I don't know what they are doing. I know what I do, but I don't know the other. But for those that keep this kind of like renewed perspective, what I wanted to say is simply, it is important to collaborate with the OEM. And the reason is basically that the OEM is the one that knows the most about their product. The same way that you know the most about what you do, they know the most about what they do. And so oftentimes you might have to, like, we are aware of organizations that have developed very expensive tools to try to interact with devices. And basically they could have just reached out to the OEM and spare that price. You also, for example, if you had an incident or something weird is happening, they might be able to help you. There might be many different ways in which they can support, which I'm going to get into. But just to give a quick example, after this talk, if you were going to the main stage to hear about InController, basically for that research, for example, of course, we started analyzing one of those big pieces of OT malware, and it's amazing. And the first thing we do is we actually reach out to the vendors, and then we talk to them, and they were like, hey, we think there's something with your product. And besides from all the research that we do, that it's pretty amazing and whatnot, they jump in, they started analyzing, they started reproducing, and then they can verify, it does affect these specific products, it doesn't, we believe it might be these industries. Basically, all of that additional information that the vendor is able to have, that you as an external individual, an external group, are not going to be having access to. And so this is just a summary of the benefits that I was mentioning. Of course, this helps you to be prepared to acquire data. They might be able to help you to have different types of visibility, of course. They also might be able to provide you with replacements or, for example, software licenses if, at a certain point you might need it because something happened and then you need to make some rapid changes. So having this type of communication is what's going to help you to immediately be able to jump and do something about it. Just a reminder, all of this is during the preparation phase for the incident response framework. So all of this is just something that we need to have in mind and that we need to have prepared so that by the time something happens, we are actually able to respond. And we get to the third step. The third step, data identification and collection. This is actually the most complicated. And just to let you know, well, I'm going to get into a disclaimer in a second, but we're going to be providing a training more into this specific area. Actually, Glenn Chasen, somewhere around here, Chris is drunk, Ken Proska, who couldn't come, they will be sharing some information about how you do that. In case you're interested, just saying, on Thursday. And so for data identification and collection, we separated in two pieces, right? We separated the physical components from the digital. Both of them we consider equally important because any change from any of both parts might be very important for the device. It is not important to go through each of these pieces. However, it's something that we provide you to be aware, to keep it if you want. There's also a blog about this where you can find all of these graphs and information. But basically, the point is, at the physical level, we want to know, what's the device, what function in general does it provide in the process, where is it located. You might be interested in having some pictures, even the physical situation, like here we mentioned temperature, because for example, if there's a difference in the temperature at a certain point in time, it might be that the device is working differently. Is there a reason why the device is working more than normal? Yes, no. Those are the type of things you might be able to respond. At the digital level, it's basically everything we see from the computer side. Of course, we want to know what framework does it have. We want to know the network traffic. We want to know the logs. We want to know errors. We want to know basically what you would go and analyze in a traditional, let's say a traditional forensics exercise, whether OT or not. And then we combine all of these together, and based on that is that we can make some of the decisions. And of course, it doesn't mean that you have to have all of these pieces of data for each device that you have. What it actually means is that you have to go and select based on the device, based on the criticality, based on where it's hosted, and then make the decision about what are the pieces of data that you have access to, and what are the pieces of data that you believe might help you in the event that you have to respond to an incident. That being said, there's our first disclaimer here, that is that we are talking about forensics, so everything that we are discussing right now is something that you should always analyze, keeping in mind these three big principles, right? That is basically the order of volatility, going first for data that is more likely to get lost if you don't respond promptly. Documented chain of custody. You need to know who was the person that was gathering all this data, when did it take place, how did it take place, and of course the evidence preservation. And so that was basically the framework itself. It's as you can tell, it's basically meant to be a high level, some high level guidance on how can we go and systematically adopt an approach so that we can go and try to make this effort of DFIR much more efficient, right? But let's try to give some example of applying the framework, right? And for this, there's a big disclaimer. The disclaimer is, right now, in this, I think, 9 minutes with 30 seconds, I am not going to be discussing and showing exactly how you're going to do this with every device and making you an expert in DFIR. What's going to happen right now is we're just going to walk through one example of a device that we were working with. If you want to be the expert, go to training on Thursday, and you can start getting more involved. But basically, this takes a lot of work because each device is different. Each device works differently, and you have to know what tools to use to interact, how are you going to interact with it, how you're going to work with it. That is the reason why we're calling for this systematic approach. It is, at this point in time, something overwhelming. So we're dropping this first analysis to say, like, okay, how can we make it a bit less overwhelming? And so the first thing is we chose this D20MX. That's some courtesy from that Chris Eastern was able to help us obtain, that we've done some research with these devices before. Basically, the first thing that we went is to find some documentation. And just to let you know, we did not use anything proprietary. All of this exercise is basically, everything was online. We went through the documentation, started finding about the tools that they used. So for example, there we found for the D20MX and sgconfig, basically for the tools to interact with the device, we found everything online and we were able to go from there and to learn it. And then also some general specifications of what it is, from which the most important probably is this BXWorks component, for which we actually have a tool that I believe it was open source from Mandiant that, well, if you're curious, just check in this blog and you can pretty easily find it, or let me know, and I'm glad to share that with you. And so we started going through the device, and this is a bit of how it looks like, right? Again, this is just like over the top how it looks like, but the exercise took much more. It actually, like, we had some of our guys building the lab and going through it and whatnot. This is a very quick and simple setup where we had like this first connection, the serial port, which was, surprise, it was us. It was a Windows computer. Then you have this port connecting to Ethernet. We had two not active and not blocked ports that, might be very important to know that, because you want to know what type of ports you have, you want to know if they're active or not, and then you want to know if they're blocked or not. And based on that, you're going to make a decision. And then you have here just the normal power supply, right? If you see a change in this, obviously that might be something concerning. We also documented the other side, and these are the pictures that we're talking about. This is, as you can realize, when we go through this is a very small lab setup. But if you actually have it, like in the plant or whatnot, you're going to have this much more complicated. A ton of cables. It can get really crazy. So the best documentation you have on this, the most likely no one's going to go and connect something around here without you knowing. So in this case, again, we documented what ports they had. We documented the power termination block, device numbers, the location. I promise they exist. They're just behind this thing. But basically, all the information for the device. And this is pretty much over the top. I insist, being such a small lab, this is less critical. Being in a larger setup is going to be more critical to know specifically what is there in place. The next one, we jump to the digital, which is a bit, it gets a bit trickier. And we decided to use two different tools. The first one, and we just chose them based on what documentation we found available. We chose them based on what we thought might be useful and interesting, and basically the best ways we could find to interact with the device. Both of them are pretty friendly, so actually it's some great news for the D20MX. The first one was basically the shell that it has. It has, I believe it was D20MX has 3 shells. We chose one of them, D20. We chose it because it was friendly and basically like more similar to other type of shell interaction. And then, immediately we go to see what are the capabilities of that shell. And then we get the list of basically capabilities that it has. We're not going to go through the entire list, of course. I mean, that's part of what we're saying, that each device is going to have its own peculiarities, and you can choose which of the data you want in here. But of course, I mean, we have to take some time to at least, go and pick up, like cherry pick a couple of the devices, a couple of the commands that we thought might have some value, right? So of course, like we were thinking, it might be interesting if you want to dump the memory, for example. Might be interesting. It might require a lot of research, so it depends on whether you have, a person with the skill set to go through it and to work with it and whatnot. But assuming you do, that might be very interesting. Of course, you want to know the routing table. You want to see if there are any changes in configurations, or for example, IPs at the network level. You want to know all the errors and user logs. Once again, if you realize this is just a set of commands that we chose, but you can basically choose depending on what your device, what the purpose is, and how do you think you're going to be best able to recognize if something changed in the context of your process, right? So anyway, this is kind of like a way to make it a bit more specific, provide some guidance into how you would go about working with this tool if at the time you get in a rush to go and respond. Then the second one, which is personally my favorite, is we used sgconfig, and the reason why I find it so nice is because I'm one of those people that really love having a user interface. I know that command shell can be, that the shells can be much more powerful in theory, but always having some visibility into this also reduces the technical requirements from the employees that you have. As long as they understand the process, it's going to be more likely that everyone's able to use it. So this one actually is much more visual than the former. But we did with sgconfig. I mean, of course, it has like more functionalities, but the quick thing that we found a super quick value in was what happens if we just go and drop the different configurations. And specifically, sgconfig can drop the configurations in XML, in a CSV, I don't know, different formats. And then we dropped this XML and we compared it with a different one to see, if there was a change. And as part of our exercise, of course, we did this comparison where we found a specific table that contains information about like registered users and passwords and whatnot. And we made a small modification to say like, okay, this is how it looks like. Now I create a backup admin. I leave a message for myself. Look how great I am. And then, I can basically show a very quick comparison that was possible because you already know that you have this tool that has the capability to go and compare your configurations, right? And so, the key takeaway from all of this, more than focusing on the specific D20MX, that's just an example of, like how to make it very, very punctual. Like in a couple minutes, we basically walked through the list of ways in which you can communicate with a specific device, what might be of value, and then basically that, when we apply it in the larger framework, becomes some guidance that you can use whenever something is happening, right? So you take these 4 or 5 takeaways. That is, the first thing is, yes, we need a systematic approach. That's what we are vouching for at this point in time. And I hope you might find this useful. I know that there's still challenges for applying it at a large level. It still requires a lot of work. But we definitely thought that it was good to start building these type of frameworks in the case of OT, because all of this is pretty well documented for IT. In our case, as we just showed, it's a bit more complicated. So yeah, basically having frameworks helps make your life easier. The second thing is about the collaboration. We highlighted a second ago about the original equipment manufacturers, how you really want to make sure that you're collaborating with them, but also within your teams, at the operational level, engineering, IT, whatever departments, because for this type of analysis, you need to have a combination of all of those skills, as we proved also within our immediate team working on the project. Then the next thing is that, just a reminder that whenever you work on anything related to DFIR, there are things that are already going on in your organization that you can actually reuse, both at the engineering and at the network level, let's say. And well, basically you can benefit from that, and even other units, other groups might also be able to benefit. And finally, well, yeah, it's just keeping in mind this is something that most likely in this audience is not even needed to highlight, but engineering personnel can share tools and knowledge that might be very useful for this detailed forensics process. That's something that we add basically because we want to highlight, like how we are trying to merge these two cultures. But in the end, I'm pretty sure that at this point in time, everyone in this room is already aligned with that and already in agreement. That being said, general recommendations. I'm just going to get in. I probably already repeated this a bit, so I'm just going to close highlighting the three things. One of them is the collaboration between the three departments. The second one is making sure that you incorporate all of this analysis into a process, because if there's no process and you can't repeat it and it's not systematic, then you're still stuck in the same difficulty once there's an incident response. And finally, awareness, which is basically, well, please, if you find this interesting, if you're passionate about this type of analysis, if you can help us pass the word and try to make sure that more people try to come up with these frameworks and with better ways to make this systematic so that you can actually do an analysis at higher levels, we're going to be super happy. And of course, make sure that within your organization, that is something that is taking place. And that is all from me now. Thanks a lot. This is the actual team that was in there. You're going to meet at least a couple of them in the training if you decide to join us on Thursday, hopefully. And yeah, thanks for everything.